Hello, we are start the webinar today with the Stockholm Institute or Environment Institute, and give me another minute to set the whole thing up and to share also the presentation with you, and I'm ready to start. Welcome everybody to the episode of the NDC Spotlight, 10 minutes with the Stockholm Environment Institute. My name is Ben Hackman and I'm working here at the UNFCCC Secretariat, and I'm very delighted to have you all with us today, and also to have our guest Charlie Heaps from the SEI with us. As you know, the NDC Spotlight is a series of short on dialogues with experts, and also with us here in the Secretariat to discuss about different aspects of national determined contributions, or the NDC. Is one of the centerpieces of the Paris Agreement, and currently in the climate world, one of the hottest to discuss. We're hosting this NDC Spotlight every 2 weeks. In each of our episodes, we are addressing a different aspect of the NDCs. So we are also inviting governments to present their NDCs and also talk with experts about these to help countries implementing or assessing these NDCs. As of today, at our session, our guest is Charlie Heaps, who is a senior scientist at the SEI. And he will introduce the SEI's long-range energy alternative planning system, or short, the LEAP, which many of you certainly already know. And he will also talk about how this system has been used to inform and also analysis to help countries develop and prepare, and hopefully also in the future implement their NDCs. Before we start, I would just very shortly share a couple of housekeeping rules. We will first hear the presentation, and there we will engage in an interactive discussion with Charlie. And for that, I would like to ask all of you to really participate, and you can do that by using the chat function in this webinar software. So you shoot your questions, and I will read it out, and Charlie is the one who has to answer it, or hopefully to answer it. And although we are recording this webinar, and it will be on our website and also on the web, the UNFCCC, where you listen to it at a later stage, you just download it and information that you want. We also presentations, and also for all other and previous webinar series that we had so far, so that you can at previous sessions, you can check the presentations, and you can also contact us directly in case you want to present something or you have ideas, and can use this series or what else would be interesting to have on this channel. To do, we welcome all comments by email. For that, please send us an email to ndcs@unfccc.in or visit our website, unfccc.in. With that said, I will hand over to Charlie.
Thank you, Ben.
Wait,
and I guess I need to have the screen at some point.
Just 1 second. And you are the presenter and can screen. And well, thank you for being with us, and the floor is yours.
And good morning, afternoon, and evening to everybody. Taking a bit of a liberty here with my presentation, I've expanded it from 10 minutes with LEAP to 20 minutes with LEAP, but I'll try to keep it a bit briefer than that. The event that you're able to see the screen properly.
See your slide properly and also hear you very well. Thanks a lot.
Okay, thanks very much. Okay, so what I'm going to try and do this morning is just to give you a very brief introduction to LEAP, talk a little bit about some of the challenges in doing the kind of analyses that support INDCs and now NDCs, give you a little bit of flavor of how LEAP can be used to help with that. And I'll mention some of the new features coming in LEAP later this year as well. And if I've got time, I'll try and give you a very quick demonstration of the software itself, which is always a bit of a high risk idea, but we'll try and give it a go. Again, what is LEAP? So for those of you who are not familiar with it, LEAP stands for the Long Range Energy Alternatives Planning System. Windows-based tool that started out originally for energy planning, but now increasingly also being used for greenhouse gas mitigation assessment, out by us at the Stockholm Environment Institute. It's been very widely applied, and most countries have used it at one point or another, and at least 32 countries used it to help develop their initial INDCs. The idea behind LEAP is that it's a scenario-based modeling tool. It's a tool that helps you explore how energy systems and emissions from energy systems might change in the future. And the idea with scenarios is to sort of create consistent, plausible stories about how things might change in the future. So you can create sort of baseline scenarios that look at what might happen if policies don't change very much. You can explore scenarios where you're doing a lot of actions, particular context on greenhouse gas mitigation, but they could be other kinds of actions. They could be anything that's sort of alternative policies that might impact an end system and its emissions. We've used LEAP at the national scale, but it has also been applied quite widely now at other scales. In particular, a lot of cities are beginning to use it through initiatives like the Covenant of Mayors and other initiatives. Some regions have been using it. But in Southeast Asia, there's a lot of regional energy and climate planning going on. Indonesia has been a very big user in that respect. And a number of examples of multi-country and even global analyses. An important point about LEAP is that it's really not just about modeling. In terms of how it compares to other modeling tools, there are other modeling tools out there. LEAP is by no means the only one that you might want to consider for developing analyses for an NDC. There's other models out there that are probably more sophisticated than LEAP in terms of their modeling algorithms and their modeling capabilities. LEAP is a very capable model, but I think the main point about LEAP is that it's not just about modeling. It's designed to help with all the other sort of related tasks. So it's so the effort in LEAP has gone into making a sort of a user-friendly overall software package. It also supports things like data management and documentation, results visualization, and it even has sort of abilities to help you sort of sit down and communicate with stakeholders. In terms of its greenhouse gas modeling capabilities, it's able to look at all of the greenhouse gases as well as short-lived climate pollutants, LCPs. It can also look at local air pollutant emissions. Into the energy system, it can also help figure out the economic costs of your policies. It can also look at related topics like energy security, resource requirements, and technology and activity trends. It clearly follows the IPCC greenhouse gas inventory guidelines, but I think one thing that's important to say is that really you wouldn't want to use LEAP to do your greenhouse gas inventories. There's already very good, well-established tools for doing that the IPCC's produced. LEAP starts at the point where the inventories stop. So the inventories are all about sort of figuring out your sort of historical and current data and what your current emissions are, but LEAP is a tool to help you think about how those might change in the future whether it be under a baseline or a policy scenario. About mitigation analysis for NDCs, I think the first point is that greenhouse gas mitigation analysis is significantly more challenging than doing greenhouse gas inventories. Three reasons. Greenhouse inventories are about data, right? They're about collecting what has happened in the past and doing a very good, accurate job of that. Mitigation analysis is about thinking about the future, which by definition is inherently unknowable because it hasn't happened yet. Analysis is also an inherently political exercise. It's about envisioning alternative energy and development futures. So it's not something that has a right or wrong answer. It's something that's about envisioning your development future for your country and what that means in terms of emissions and what that means in terms of potential for emissions reductions. And it also requires a sort of a bottom-up or end-user oriented modeling approach. In order to think about the impact of different mitigation policies, you really need to be able to say something about technology trends and how they might play out under alternative policy scenarios. It's not good enough just to have, the total fuel use multiplied by an emission factor to give you the total emissions in a sector, which is the kind of thing you do in a greenhouse gas inventory. To do mitigation well, you really need to start thinking about what are technologies that could be emissions and how might those technologies change in the future. So you need to know things about sort of, what kinds of lighting do you have, what types of vehicles might there be on my roads in my country now and in the future. Because mitigation analysis ideally requires quite detailed technology and activity data, and that's a real problem because much of that type of data is unavailable or of very low quality. And that's particularly true in developing countries. They typically have much larger data availability challenges, and they also only have limited capabilities or limited human institutional capacity for working on these kinds of issues. So what countries have tended to do in the past is to outsource their mitigation analyses to consultants. But that, I think, has led to much less local learning than you'd really like to see. And it also helps explain, I think, why sometimes mitigation plans don't get fully reflected in national development plans. While we can't address all of those are very big issues and they can't all be addressed in a piece of software, of course, but we have to design LEAP to help with some of those kinds of issues. To mention a few of the ways in which LEAP is designed to try and address some of those challenges. First, designed to have very low initial data requirements. You can get started with LEAP with fairly minimal amounts of data. So that makes it useful in situations where good data is in short supply and where human and institutional capacity is fairly limited. It has a fairly user-friendly design, which I hope I'll show you in a second, and emphasis on results communication. So that helps make the NDC analysis process more broadly accessible. So people engage with the LEAP who aren't necessarily expert modelers. It's also accessible to planners, decision makers, and other stakeholders. The design of LEAP is very much sort of a demand-first, end-use oriented structure. So that helps frame the mitigation analysis within the broad development goals that a country might have. It's a fairly sort of fast, interactive design, so you can quickly explore and calculate things. And that encourages people to take an iterative approach to building your NDC analysis. Very important in cases where you have limited capacity and you want your analysis to be a learning approach in and of itself. It's got a very bottom-up, or it encourages you to build a very bottom-up end-oriented modeling structure. So that's very well suited for exploring technology-oriented climate policies, which is very much what you need to do in mitigation analysis. With more details about LEAP, structure of LEAP. I won't go into it in a lot of detail, but I just mentioned a couple of things. The main spine of LEAP, you can see coming down the middle here. It's a demand-driven calculation. You start with LEAP by building energy demand analysis, looking at where you're consuming final energy in your energy system of your country. So there you'll be thinking out things like households, industry, transport, commercial sector, agriculture, those kinds of things. So you're looking at what the sectors look like, what kind of activities are going on, and what energy requirements to produce those activities. So for example, in households, you might be looking at things like cooking, lighting, heating, space cooling, those kinds of things. In transport, you're looking at different modes of transport, road and rail. In industry, you're looking at all the various industries that consume energy in your country. So those kinds of things. So building a picture of how you use energy in your country, which is pretty much the same kind of thing that you do in a GHG inventory, but then telling a story about how those things might change over time. Your economy will growing, your population is likely to be growing, all things put pressure to increase emissions, but explore what kind of policies might be available that might lead to reductions in those emissions going forward. So it's about sort of doing basic accounting in the system and then exploring different policies and how those might lead to the reductions in emissions. So analysis, that's where you look at final energy consumption and the implied emissions. Then you have transformation analysis a bit further down, which looks at how you produce your final energy. So that's where you explore things like electric generation, oil refining, sort of modern sectors, but you can also look at sort of traditional sectors like charcoal making and bioproduction, for example. I guess that's a modern sector. Finally, down the bottom is resource analysis, where you can actually keep track of all of the flows of resources required by your energy system. That's where you think about things like production of fuels, production of renewable resources, and also things like imports and exports of fuels. Basically, a model of your energy system of your country. And added to that, there's a place where you can look at non-energy sector emissions as well. So LEAP is primarily an energy sector model, but it does have the capability to do some non-energy sector greenhouse gas modeling, either in sort of fairly simple terms within LEAP, or you can easily incorporate results from other models. Key strengths of LEAP is that it's very good at sort of talking to other models and incorporating results from other modeling tools. The sort of main spine of the calculation down the middle, and then sort of hanging off the side, we have two kind of additional calculations. We have the environmental loadings, so that's a place where we can put in all of our emission factors and calculate overall greenhouse, local air pollutant, and short-lived climate pollutant emissions. And then on the right, we have integrated cost-benefit analysis. That's a place where we can look at the sort of different policies. So we can look at things like the capital, operating, maintenance, and fuel costs of whatever policies we're interested in, and we see the overall costs of one scenario minus another, typically expressed in things like sort of net present value. So, you know, a single number that tells you in one scenario more expensive than another. A few other bits that I haven't mentioned. So it is possible to include environmental externalities. So if you know a sort of damage costs associated with pollutants, you can incorporate those into your overall integrated cost benefit analysis. And a new feature that I'll tell you a little bit more about in a second is the impact calculator, IC, which is the emissions from LEAP and uses those to give you some idea of health impacts and ecosystem impacts of, or rather avoided health and ecosystem impacts of policy measures. So lets you look at things like avoided mortality, avoided crop loss, those kinds of issues. I'm actually running out of time very rapidly, so I'm going to skip over these more detailed screens, and I'm going to go straight to LEAP and actually show you some hints of what you can do in LEAP. So before I do that, let me just mention a few more basic logistical issues. So if you're interested in using Leap, how do you get it? You can download it from this website here, www.energycommunity.org. You do need a username and password to fully enable software when you download it, and we provide those to licensed users. So you can apply for a license on the website. Licenses are available at no charge to non-profit, academic, and governmental institutions based in developing countries. If you're not one of those kinds of organizations, there is a fee to purchase a license for Leap. The website does have a very comprehensive amount of information on it. It does also have technical support forums where you can ask questions, or you can email leap@eia.us.org for more assistance. One Leap is, it's very easy to say that a piece of software is user-friendly, but that doesn't mean that doing a mitigation analysis is an easy thing to do. Our Leap is to try and make mitigation analysis easier, but I wouldn't say that we've made it easy. So you think that most users will need some training in order to use the software. If you're interested in that, you can contact us by at that email address. And we're available, SEI is available to give training, or regional partners around the world who can also be available to give training. And if we're running any regional workshops, please do check the website, because quite often there are regional workshops going on, and we will announce them on the website, and you may be able to attend one of those as well. That means if you're coming soon in Leap, there are a few major developments coming, hopefully by the end of this year. So first, there's this thing I've already mentioned, this new integrated benefits calculator, Leap IBC. This tool is designed to calculate avoided health, ecosystem, and climate impacts of policies. So it actually takes the emissions from Leap, feeds them into another model, which I could probably spend an hour telling you about, but I won't. And that model is used to calculate avoided impacts. And so this model is on look at short-lived climate pollutants, but it also is useful thinking about local air pollution issues. That we're testing at the moment. We've tested it in 4 or 5 countries, and we're currently working on calibrating it for 100+ countries, and we hope to release that near the end of this year. And will just be, when it released, an add-on to Leap. So if you're using Leap, you will be able to access that. Major part that we're working on at the moment is ability to do land-based modeling of distributed resources. So particular focus on biomass energy, both traditional and modern biomass, but also we think this should be useful for thinking about wind and solar. So the basic idea there is that you can look at your country, divide it down into regions, and then think about the different land types within those regions and how those land types might be changing. And you can use that as a basis for thinking about what's the availability of renewable resources on those land types, and integrate that into your overall energy modeling efforts. So we're just about finishing that we're doing some testing of that at the moment in Rwanda. We hope that part of the model will be included in the upcoming release of Leap, which should be, as I say, before the end of this year. A few other things we're doing, better modeling of energy storage, updated platform for the software. At the moment, it's 32-bit software. Some people are running into the developing models that are too large to run within Windows. So upgrading it to the 64-bit version, which should be able to hold very, very large models indeed. And various other smaller improvements with the basic sort of goal of making tasks much easier within the software. So that's a short presentation. Bernd, okay, if I take another 5 minutes to show people how it works in practice?
Sure, Charlie. Please try that, because I would be really, really interested in seeing that.
Hopefully you can see LEAP on screen now.
Yes.
Okay, I've switched over now, everybody, to show you the software, how it actually looks on screen. So you can see it's a Windows-based software tool. Here on the left, we have different views of an energy system. That's the way the software is structured. So we have an analysis view, which is where you do all of your model development. It's where you build your model structure, where you create your scenarios, and you put in the data associated with the model. We have results view, which is a general purpose tool for looking at the results coming out of the model. We have a balance view, which gives you an overall snapshot of energy flows in a system using standard energy balances, the kind of things that's produced by most energy ministries. Also, the IEA produces standard format energy balances, very similar to those. And then we also have a few other views here. There's a notes view that's used for documentation, and an overviews view that gives you a sort of a bird's eye view of many different results. I'm going to show you a few hints of some of the kinds of things you can get out. So here in the analysis view, you can see over here next to that is this tree structure, which is the main data structure within LEAP. You can see we've broken demand to different sectors. We've broken transformation down into the energy producing sectors. So here's things like electric generation, charcoal production. And down at the bottom we have resources. And what's here is a very a sample data set. It's not real data. So this is for a country called Fredonia, which is our sample data set. But when you're using LEAP yourself, you would make this tree structure to reflect what's going on in your own country. Here, for example, in Fredonia, we've got households, and if I click on the tree, you can see it's broken down into urban versus rural. We have how with and without electricity, then we have different end uses, and then here we have different technologies. So the power of the model really comes from this sort of data structure and sort of gaining how energy is consumed in the country, and sort of telling a story about how that might change. Let me give you one very, very simple example. For example, under households, at the top of the tree, we have the total number of households in what we call current accounts. So current accounts for the base year. So in the tree, we have 8 million households, so 50% are urban, and then the rest are rural. And the numbers here are also echoed back to you in a chart down there. You go all the way down underneath our rural households, you'll see this. Everyone in cooking, 30 of them use charcoal stoves, some of them use LPG stoves, and the rest use wood stoves. This is where we're telling a picture about what's happening in the base year, or the first year. Then we switch over to a scenario. So that's very quickly at a baseline or a reference scenario. And you can see doing here then is telling a story about how those numbers are going to change. So our households are growing at 3% a year. So here in LEAP, we can write a little equation that describes how this number changes. So here I said 3% per year, but we could do something more complicated than that. We could say, after 2020, we're at 1% a year. So if I center it, immediately the line changes. So that's how LEAP is basically an accounting framework, but it gives you tools to tell a story about how numbers might change. Here under cooking, you can see initially we had 30% charcoal stoves, but I put in a little equation here, an interp function that says by 2040 that's going to drop 25%. And the stoves are going to grow so that by 2040 they'll be 55%. The remainder will be wood stoves. So the equations there generate all these numbers you can see in the chart. Interpolate function is just saying draw a straight line from this point here to this point here. So that's where you put data into the LEAP. Now look at and that through all of the different sectors and subsectors, and to look at some results for different scenarios. So in this particular model, we have a reference, which is like a baseline scenario. We also have a mitigation scenario. So let's look at the results. In fact, let me change this back. So I made it here, didn't I? I'll get rid of that. Because I made some changes, it's going to need to recalculate recalculate. But you can see this is very quick. That took maybe half a second to recalculate. Now we're ready to look at some of the results. As an example, here we're looking at some results for demand, the reference scenario, and we've organized it so that we're showing the fuels over here. But the neat is you can chop up the results in all sorts of different ways. So LEAP stores a very big database of results, but then the results view lets you pull the results out in different formats. So here we're organizing by fuel, but I could also choose to organize it by sector. So there's those, but organized in a different way. Or I'd say, you know, I want to have fuels up here. So now it's on the legend, but I want to put the sectors down here on the x-axis. It's kind of way of seeing the results. This one is actually showing you sector fuels for a particular year, and we can even sort of look at that for years, or we could even make a video of it. We can press play and we can see how it changes. I'm not sure if you can be able to see this. The screen might not refresh quickly enough. This is basically using an animation of how the numbers change over time. So for all sorts of results coming out of LEAP, that was our energy demand results. Let's look at the total greenhouse gas emissions. So instead of energy demand, I'm going to look at 100-year global warming potential numbers. So that here for the country whole, and we do it by year, it's a bit more interesting. So the total greenhouse gas emissions change over time in our reference scenario or mitigation scenario. The different emissions, these are organized by fuels, but we could also organize it by branch to say, how much have I saved relative to my baseline scenario? So this is just plotting the mitigation numbers. I could choose to show, for example, what have I avoided versus my baseline or reference scenario. You can see the colored in bars are the mitigation scenario. The dashed bar is what you avoided versus your reference scenario. So those are the kind of results you can get out. You can get lots of results out of LEAP. You can get maybe thousands of different charts out of it. There's just a few examples there. Let me show you a couple more things. That's very detailed result. We can also look at sort of high-level results. For example, you might want to look at the energy balance for your country. So I'm switching over to this view here. So this is a snapshot of how energy flows through country in a particular year. This is the kind of thing, if you've ever seen the IEA's energy statistics, this is very similar to that kind of approach. It's a way of summarizing energy consumption, which is the bottom section, conversion, which is the middle section, and energy production, which is the top section. And by convention, a negative number means that the fuel's being consumed. So here you can see, for example, here's coal being consumed for electric generation, hydropower being consumed, and then here's electricity being produced. And that's one way of seeing it. One of the things you can do in LEAP, though, is you can say, what will my energy balance look like in the future? So here, for example, we could say, what's this energy balance going to look like in 2040 in, say, the mitigation scenario? So you can numbers, or you can actually plot it as a Sankey diagram. I'm familiar with the Sankey diagrams, but here is a Sankey diagram. The diagram is really just a summary of the energy flows going through a country. And here we've got in LEAP, we're summarizing, here's the basic resources being produced, and then here's the consumption of the fuels in different sectors. So it's showing you how you get from one to the other. And here's like the losses of energy, which is typically a very big number in most countries. So that's a Sankey diagram. I'll show you one more example. I'm only giving you a hint of how it works, obviously, but I'm going to do a different example here of how you can use LEAP to communicate with stakeholders. So this is another sample data set I've got here. And we have the different results in LEAP. And one of the things you can do is you can bookmark results. So just like using Internet Explorer, if anyone uses that anymore, I suppose they don't, you can save bookmarks for your favorite results. his favorite results down here. So I've got one that shows, for example, generation mix in 2 different years. Here's one showing any demand over time. That one's not working. So look at a different one. Energy security, sort of an indicator of energy security in 2 different years. Once you do those favorite charts, you can plot them all together in an overview. So let me show you that. We have a group of different charts all plotted together in an overview view. See, one of these shows you how greenhouse gas emissions change over time. Another one gives you an idea of energy security. Another one gives you an idea of the total cost of the scenario. And there's other ones as well. And at the top here, we have different levers. These levers reflect what level of policy you did in a scenario. So here, for example, how much energy efficiency we did. So this is saying that building efficiency is improving at 0.5% per year. Industrial efficiency is about the same, with 0.9% per year it's improving. So when levers are actually attached to variables in your LEAP model. And what we do once we've created an overview is we can actually let people play around with scenarios and recalculate them on the fly. So let me see if I can do that. I'm going to actually create a new scenario here by right-clicking here. So I'm going to create a mitigation scenario. Initially, let me refresh the screen. The screen is actually recalculating the behind. And you can see initially the mitigation scenario is exactly the same as the baseline scenario because I haven't pulled any of the levers yet for mitigation. So I've got all the same policies. So therefore you can see all the results are the same initially. The scenarios cost the same, they have the same energy security. You can even see the blue line there, it's hiding behind the orange line, but we have the same GHG emissions. So what we do now is let people, once you've built your model, you can sit down with your stakeholders and let them engage with it. So they might want to do a lot of building energy efficiency. So let's try that. Let's do a lot of building energy efficiency. Let's risk it, and then let's see what cause to happen. It doesn't do a lot. It reduces emissions a little bit, has a little bit of impact on energy security, and actually is a bit less expensive than the baseline scenario. Let's try and do something a bit more radical. Let's do lots of electric vehicles. This one is a bit counterintuitive. We're going to do a huge amount of electric vehicles. We're going to and you can see the difference. You would think that would be, it's cost a lot of money, so the cost has gone up, but it's not a difference to greenhouse gas emissions. Well, the reason for that is because we haven't done anything on the supply side to match it. So we've gone electric in terms of transport, but we haven't done anything to improve the generation mix. And then we put labels on this. So you can see the generation mix is still very much coal-based down here. Look at that. Combine our electric vehicles with saying we're going to have much less coal, but we're going to have more wind, and then if that makes a dramatic difference. A big difference now. So now we've really made a large reduction in our greenhouse gas emissions at some cost, but we've made a large reduction in our greenhouse gas emissions, and we've dramatically changed the generation mix. So I wanted to show you that a few examples of the kinds of things you can do with LEAP. And I think my time is basically up, so I will leave it at that, and hopefully there's some questions. Thank you very much.
Thank you, Charlie. This was really impressive presentation, and I'm really glad that we managed to have this live presentation of the model, and also that you took the time to these two scenarios run next to each other. It's really impressive, and I think that aligned the presentation that you did before. When we presentation, we have questions, and I try to structure this a little bit. we basically have three sections. One is a little bit about the capacity requirements. One is about using the model and also customize it. And one is about, because you mentioned that, I think in one of your earliest slides, is about your support for the INDCs. Maybe this one might be the easiest one, and that is, what are the capacity requirements? Like, what kind of use, say, are best suited to use this, and what kind of capacities or these people should have, and then also which format is the data input that is required for the model. If we can start with these two questions, that would be
okay. The first question is, I think it's probably the most important question. So I don't want to tell you that doing, a detailed mitigation analysis is a simple thing. It's not. It's a very serious undertaking. What we've been trying to do with LEAP over the last 25 years is sort of broaden access to that kind of activity and make that kind of activity doable by a broader group of people. I would say 20 years ago, this kind of stuff that I'm showing you was done only by sort of quite academic people who were modelers, and there was a big gap between sort of the modelers and decision makers and the planners. So they didn't talk each other's language very much. What we've tried to do with LEAP is sort of take something that is quite a difficult task, but make it much more accessible. So now I think it's possible for a much broader group of people to get engaged. You probably do still need people with some level of comfort in modelling, but we people using LEAP who are not professional modelers, they're more like planners, I would say. You definitely do need training to do it, but I think if you're good with Excel, if you're good on energy policy, then you can have a reasonable chance of using it. But I want to make it sound like an easy thing. You do need a reasonable amount of training. You do, more important than the modelling skills is you need people who know a lot about the various different energy sectors you're talking about. So you need people who can think practically about what mitigation policies in the transport sector. So you probably need a transport expert, you need a buildings expert, you need an economist, you need someone who's familiar with the electricity sector. So I would not recommend having sort of one person being able to go off and do the modelling. I think you need a team of people who can connect together. Maybe you have a sort of a younger PhD type person who can actually be the person who sits down with the model, but the most thing is to have a group of people working on it together. I think it's very doable. And now I've forgotten what the first part of your question was.
Well, actually, we're both going in the same direction. It's like, what kind of capacities are required? What kind of people actually use that? But I think you answered it well, and that brings us already to the next set of questions, because you said you need a team of people that know their whereabouts, that know what they want to do, and they know the sectors and want to address. So next set of questions that we received was really about this, like, how much can you customize this model? For example, one question was, more demand sectors. Is it possible to illustrate levels of analyze supply and demand of natural gas in a seasonal manner? All these kind of, I would say, very detailed questions.
Yeah.
Maybe even I would really to ask you whether you could be available for answering these questions online, because I think this is more
certainly
something very, very detailed. And if you could put, you had one slide where you showed how you can, where you can get LEAP, where you can find it, and there was also an email address. That would be very, very helpful. And a question while you are doing that is, could you theoretically also use LEAP to instead of simulating a modeling for a country, modeling for a specific sector? Let's it's really about how far can you customize this one.
Yeah. Okay, we'll have a bash at that. Yeah, you can customize it a lot. The data structure is very, very flexible. Sort of like sort of four main levels of flexibility in software. The first is that the data structure, that T structure I showed you. You can change that almost any way you like. You could just have sectors broken down by fuel, or you could have sectors broken down by income group, by urban, rural, by end use, by technology, and there's no particular limit to the sort of size of the tree. I've seen people do sort of models of iron and steel broken down into sort of milling and rolling and blast furnaces, and you can get into incredible levels of detail if you want to. And kind of a nice thing about the model, the algorithms are relatively simple, but a lot of the model comes from sort of the data structures. So you do a lot in that. Those sort of choices and models available. So there's not just one method. We don't say this is the way you have to do it. We try and give people sort of different methods. So we try and give people some methods that are, have low data requirements, but maybe don't have quite as much explanatory power. And then you can sort of step up to more sophisticated methods if you've got a bit more data available, or if you to take the time to sort of learn how to use those methods. So for example, in electric generation, you can do something really simple. You could just take the results from another study and say, in 2050, we'll have 50% wind and 10% coal and 30% hydro. You can build a model where you look at capacity expansion, you divide, you look at dispatch in different slices of the year, and use sort of simulation modeling or optimization modeling. So there's lots of different sort of choices and methods we make available. So that's kind of the other flexibility, the second flexibility. The flexibility is that LEAP is very good at sort of talking to other models. So you can either do modeling within LEAP, or you can kit it up to other spreadsheets or to other models. Very easy to import and export data. So, you don't have to do all of your modeling in LEAP. You could have people sort of develop numbers offline in spreadsheets, and then you just pull them automatically into LEAP. So it's kind of like an integrating framework. It doesn't have to do everything. It can just be sort of the overall integrating framework. And the kind of flexibility is that it also has what's called an API, an application programming interface. So if you want to, you can actually program LEAP, or you can use another piece of software to control LEAP. For example, when we've been looking at uncertainty, so itself is not stochastic. It calculates. One scenario has one result in LEAP, or it has one set of results. But sometimes you want to look at sort of uncertainties and probabilities. So, for example, when we were working with Mexico, they wanted to look at, what range of uncertainty about the emissions projections in 2050. So we looked at the key inputs to LEAP, and then we Monte Carlo analysis. So we're actually sort of doing random sampling of key variables, which assume have certain probability distributions, and we're using that to generate the input values for LEAP, and then we're running a particular LEAP scenario many times, like a sort of 1,000 times, and then we're looking at the attribution of the emissions projections. To do that using the API, you can use Excel and other tools like, there's a tool called Crystal Ball, which is an add-in for Excel that does Monte Carlo analysis. So use tools like that to drive LEAP using LEAP's API, its application programming interface. Sorry, that was a very complex answer. But so there's a lot of flexibility in short.
Thanks, Charlie. I have one problem. We are running out of time, and the more you talk, the more questions we get in.
Sorry.
These questions are really very, very interesting and very detailed questions, but I think they're really, I think the more you would then go into these questions, answer them, you wouldn't receive more questions.
Well, let me say this, but people can, what I say is, if you have questions, it might well be that someone's already had the same question that you have. So please go and have a look at the website. Go and join the website. It's free. Discussion forum on there, which already has thousands of questions posted and answers to them. So look there first. But if it doesn't answer your question, feel free to post another question on the discussion forum. very active discussion forum. We have maybe, I think, at least 30,000 members on the website already. So there's, chances are if you post a question, someone will answer it.
That's great, because I can clearly tell that it must be a very kind of live active forum, because this is, I guess, we get a glimpse of what is happening there right now. Because of this demand, and also because we couldn't even go through all the questions, I would like to invite you for another webinar next year. May have also some updates to present by then. That would be great if we can do that in a year or so.
I'd love to, yeah.
That said, because we really extended or went beyond our 10 minutes or 20 minutes, as you said, we have to come to an end. I would like to thank you, Charlie, for this great presentation, and especially also for showing us the live model and how it's really working. I'd like to turn everyone's attention to our website, because the presentation will be there. Contact details also for us will be there, and also we are recording this webinar, so you can watch this webinar and listen to Charlie and the presentation, also to the example he was presenting wherever you want. Please send us ideas and comments, ndcs@unfccc.int, and also if you want to be part of the mailing list and be informed about upcoming webinars, please also just send us an email. We are now having a short summer break here, even though look out of the window, there is not much summer, but we still have the break. Next webinar will be held in September, 14th of September, so it's a little bit less than a month from now. It's very likely to be Argentina presenting their NDC, so watch this space, and thank you very much. Have a good afternoon, evening, or morning to everyone. And again, thank you, Charlie. Thanks very much.
Bye.